Okay, question 7. There's a two parallel slits separated by 0.255 meter illuminated by a 546 nanometer green light. So the interference pattern is observed on a screen 1.2 meter away from the slits. So we have to calculate the position of the second order maximum and the distance between the first order and fourth order minima. Okay, so sekarang ni dia bagi dua pula. So ada maximum and minima. So now we know that for a maximum punya equation, we are using ym equal to m lambda d over small d. So the capital D is equal to 1.2 meter and small letter d is 0.25 millimeter. And the wavelength is equal to 546 nanometer. Okay, so that is the information that we need, and second order is just gonna be m equal to 2 lah. So 2, 5, 4, 6, 1.2 over the small d, which is berapa tadi? 0.25 times 10 negative 3. So the second position of the second order maximum is 5.24 times 10 negative 3 meter. Okay, right, and then the distance between the first order and fourth order minima punya equation is m plus half. Dia ada plus half saja. Lupa lambda. Okay, so ini equation untuk minima lah. And then the distance is you just gonna subtract this 2. Okay, so y4 you should get 11.79 times 10 negative 3 meter, and then y1 pula you should get 3.93 10 negative 3 meter. Okay, so the distance between the first order and fourth order minima is 7.86 apa ni nama dia? Millimeter. Okay, boleh ah. Alright, so that is 7A lah. In this question, you just need to use these two formulas. Let me double check. It should be in your formula sheet. Is it not? Oh, is it? It is here, which is this one. Okay, the first two equation for chapter 8 is here, starting from number 71. Okay, now question B pula. So a monochromatic light is illuminated to a diffraction grating which has 5,310 lines per centimeter. That is the value of n, which is 5310 per centimeter. So we have to convert it into meter. 5.31 times 10 to the power 5 lines per meter lah. Sekarang baru dia per meter. Tadi dia per centimeter. And then the second order maximum. So what is that? It is telling us the value of n. Small letter n is equal to 2. So the second order maximum produced by a diffraction grating is at an angle of 35 degree. So the angle is 35 degree. So we have to calculate the number of maxima that can be seen on the screen. So this is also in your formula sheet. I think it's d sine theta. This one. Okay, so n is the number of lines you can see on the screen, either maxima ataupun minima lah. Alright, okay, so now we are looking for the number of maxima. So number of maxima, first we are going to use the equation d sine theta equal to n lambda. Okay, so now what do we have? Do we have the wavelength? No, we do not have the wavelength, and we also do not have the value of d here. So how do we find the small letter d? It is 1 over n, so this is 1.88 times 10 negative 6 meter. Okay, from there pula kita sekarang perlu cari lambda. Okay, so lambda pula sorry, so the wavelength, we are gonna use, kerja apa? Macam confusing. Oh, okay, sorry. So the lambda, dia cakap second order maximum produced at the diffraction grating of 35 degree. So we know that the wavelength should be constant. So we can use this equation to find lambda. So lambda is equal to d sine theta over n, which is 1.88 times 10 negative 6 sine 35 divided by 2, which is the second order maximum. Okay, so lambda is gonna be equal to 5.4 times 10 negative 7 meter. Okay, so from here, we can then use this wavelength in order for us to calculate the number of maxima. So number of maxima, untuk maximum, the angle for maxima order, the angle is 90 degree. Okay, remember, untuk kita cari the number of maximum lines can be seen, angle dia mesti equal to 90 degree lah. So sekarang ni kita guna balik je this equation. So this is 1.88 negative 6 sine 90 degree equal to and 5.4 times 10 negative 7. Okay, so dari sini kita dapat n to be equal to 3.48. So this is approximately 3 lah. Okay, so the number of maxima that can be seen, maxima is the bright fringe. So we are gonna times it with 2 and plus 1 for the central bright fringe. So this is equal to 7. Okay, so why do we multiply it with 2 is because we have the positive and the negative order punya value. Remember, so this is the central bright fringe, then we have the positive value bright fringe, and then we have the bawah punya negative value punya bright fringe. Alright, okay, so that is on chapter 8 and on question number 7.